Hey, it's Mr. E here. In this video, we're going to cover how can we use Pascal's triangle to help us expand a binomial. Alright, so as a warm-up, I want you to use your knowledge of FOIL, first, outer, inner, last, and distributive property to expand x plus y to the third. By the way, FOIL is actually it's the distributive property, just so you know. Alright, so it says x plus y to the third, and they want us to expand it. So that's like multiplying x plus y by itself 3 times. So to start, we could FOIL out x plus y and times x plus y. So that's going to be first, outer, inner, last, and we get this. If we combine the like terms, which are going to be the two middle terms, we simplify it and we get this: x squared plus 2xy plus y squared. Okay, now all that's left to multiply is this trinomial here by this binomial. So that's going to be x plus y times x squared plus 2xy plus y squared. So we could just start by distributing the x first. So x times x squared, x times 2xy, and x times y squared. And that's what we get. Now we could distribute the y times x squared, y times 2xy, and then y times y squared. And this is what we get when we multiply that. Alright, now we combine the like terms. So we have like terms here and here. So 2x squared y plus x squared y, that's going to give us 3x squared y. And we also have like terms here, xy squared, and here 2x y squared. So we combine the like terms and we finally get this. So this is our final answer when we expand x plus y to the third. Alright, so that took a while. Let me ask you this. Do you notice a pattern with the exponents? Well, you should notice that the exponents of the first term, I'm going to call this first term A, and I'm going to call the second term B. So notice that the exponents of the first term, they're descending with each successive term. So you have x to the third, x squared, x to the 1, and I can write x to the 0 here. X to the 0 is just 1. It's not going to affect y to the third. So the exponents of the first term are in a descending pattern with each successive term. So 3, 2, 1, 0. The exponents of the second term, b, or y, we could just say. The reason I'm calling it a and b is because I'm going to use this notation later on. So the exponents of the second term are ascending. So you have y to the 0 here. I could write y to the 0. Y to the 0 is just 1. It's not going to affect x to the third. So you have 0, 1, 2, 3. Alright, so in conclusion, we could say that the pattern of the exponents is the following. The exponents of the first term are descending, 3, 2, 1, 0. And the exponents of the second term are ascending. 0, 1, 2, 3. Okay, so here I'm giving you the expansion of a plus b to the fifth, and I want you to write down any patterns that you notice. So you should see the same thing. The exponents of the first term, a, are descending. So you got 5, 4, 3, 2, 1, and 0. And if you look at the exponents of the second term, b, they're ascending. So we could write b to the 0 here. So you got 0, 1, 2, 3, 4, 5. So we notice the same exact pattern. We might also notice that there's a pattern with the coefficients. So here the coefficient is 1. So we got a coefficient of 1, 5, 10, 10, 5, and 1. So we got a pattern with the coefficients here. Now, we notice a pattern with the exponents and with the coefficients. Let's talk about the coefficients. So we have Pascal, who was a great mathematician, who noticed that there was a pattern with the coefficients of each term of the binomial expansion, and he made up this thing we now call Pascal's triangle to get all the coefficients of each term of the binomial expansion. So let me just show you how you could look at Pascal's triangle. One way you could look at it. So a plus b to the 0, that's just 1. Anything raised to the 0 power is 1. A plus b to the 1, that's just a plus b. And the coefficient here is 1, and the coefficient here is 1, so we get 1 and 1 for the coefficients. Now here's where it starts to get a little interesting. So we're going to have coefficients of 1 and 1 on the sides, but the middle coefficient is 2, and the way we get that is if we go one row above and add 1 and 1, we get 2. Alright, so the first coefficient and the last coefficient in each row is always going to be 1. But the way that you get the middle coefficients is by adding. So for example, by adding from the top row. So for example here, a plus b to the third. To get the two middle coefficients, 3 and 3, we're just going to add 1 and 2 here to get this 3, and 2 and 1 here to get this 3. And that repeats. Look here, 1 plus 3, that gives us 4. 3 plus 3, that gives us 6. 3 plus 1, that gives us 4. So what's the big deal with Pascal's triangle? What's so important? What's so great about it? Well, what's so great about it is that Pascal's triangle provides the coefficients of each term of the binomial expansion. So if we know that we're expanding, let's say, a binomial to the 9th power, we know that the coefficients are going to follow this pattern of 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. And it does help to know that. And I'll show you how it does in a second. Let me just go ahead and erase this. Here, we are being asked, let me go ahead and, give me 1 second. I don't want to bring this up yet. Let's just ignore that. Okay, here we're being asked to expand x plus 5 to the 5th. What's one thing that we know? Well, given Pascal's triangle, we know that x plus 5 to the 5th, when expanded, the coefficients must follow this pattern. We know that. So we can go ahead and just write out the coefficients. They're going to be 1, 5, 10, 10, 5, and 1. What else do we know? Well, we know that the first term, the exponents are going to be descending. So we know that here x is going to be raised to the 5th power, here to the 4th, 3, 2, 1, and 0. And we got that from the warm-up. So by the way, this is called n. I'm going to go ahead and call this a, and this is b. So we know that b, the exponents are going to be ascending. So it's going to go 0, 1, 2, 3, 4, and 5. So if you're raising it to the 5th power, you're going to start with 5 as the exponent of the first term and then just descend. You're going to start with 0 on the second term and then just ascend all the way to 5. Now this really helps to expand the binomial, you know, because if we didn't know these patterns, we'd have to sit there for a long time and you know, do x plus 5 times x plus 5 times x plus 5 times x plus 5 times x plus 5. We'd be there forever. So knowing these patterns does help to multiply it out. All right, so 5 to the 0, that's just 1. So here we just get 1x to the 5th. 5 to the 1, that's 5. So here we have 5x to the 4th times 5. Here, 5 squared, that's 25. So we have 10x to the 3rd times 25. 5 to the 3rd, that's 125. So we have 10x squared times 125. 5 to the 4th, that's 625. So we have 5x to the 1 times 625. 5 to the 5th, that's 3,125. So we have 1x to the 0 times 3,125. So let's just go ahead and simplify this. 1 times x to the 5th, that's x to the 5th. 5 times 5 is 25, so we get 25x to the 4th. 10 times 25, that's 250. 10 times 125, that's 1,250. 5 times 625, that's 3,125. And then 1 times 3,125, that's 3,125. X to the 0 is just 1, so I don't need to write that there. So this is our final answer. So you can see it definitely does help to know those patterns. It really saved us a lot of time when it came to multiplying x plus 5 by itself 5 times. Okay, here are some steps for using Pascal's triangle and your knowledge of the pattern with the exponents to expand the binomial. So I would pause this video and write these steps down if I were you. Okay, now I want you to try to write the expansion of x minus 2 to the 5th power. Write down your answer in the comment section. If you'd like a hint, you could keep playing the video. Alright, so from the Pascal's triangle, we know that the coefficients are going to be 1, 5, 10, 10, 5, 1. And we can just go ahead and write a and b next to each one of those coefficients. So x being my a and -2 being my b. Now what do I know about the exponents? I know that they have to follow a pattern. And I know that in a, I'm going to start with n, that's 5. and the exponents are going to be descending. So it's going to go 5, 4, 3, 2, 1, 0. And I know that the exponents of each successive b are going to be ascending. So it's going to go 0, 1, 2, 3, 4, 5. All right, I'll let you figure out the rest. I hope this video helps. Take care.